students present here. I am Supriya Paudil, a third-year computer engineering student at Khopa College of Engineering, and I once again welcome you all to the National Conference on Computer, Electrical, Electronics, and Communication Engineering, Khopa SEAL 2026, jointly organized by Khopa College of Engineering and Khopa Engineering College. As a part of today's conference schedule, we now move on to the keynote session. The keynote session offers us an opportunity to gain broader insight from an experienced personality, allowing us to reflect on current developments, research directions, and the evolving role of engineering in society. It is my great honor to introduce our keynote speaker, Professor Bhupendra Bimal Chhetri, a senior academician in the fields of electrical and electronics engineering in Nepal. Professor Chhetri obtained his bachelor's degree in electrical and electronics engineering from Bangladesh University of Engineering and Technology in 1993, and later earned his master's and doctorate of engineering degrees in electrical, electronics, and computer engineering from Kyushu Institute of Technology in 2000 and 2003 respectively. Professor Chhetri began his career in 1994 as a lecturer at Kathmandu University and was one of the founding members of its Department of Electrical and Electronics Engineering. His research and teaching covers lighting, vision, optical and satellite communications, signal processing and energy systems. Professor Chhetri is also a valued member of Institute of Electrical and Electronics Engineering, and in 2006, he also received a certificate for outstanding contribution to education from the government of Nepal. Ladies and gentlemen, please join me in warmly welcoming Professor Bhupendra B. Chhetri to deliver his keynote address.
Thank you very much for giving this opportunity to me. As introduced, I am Bhupendra Bimal Chhetri, Professor of Electrical and Electronics Engineering at Kathmandu University. So, when I was called for this keynote speech, it was little bit a kind of, thinking what should I pick the topic. So when I look into my background, I have done quite a number of diverse things, but when I thought about giving the presentation, giving the keynote speech, I thought about why not to look into the future and take some hints from the past, how things developed. And also, I thought it would be nice to speak about something that connects future with, mythology. So, this my speech is a kind of, appetizer for you for coming technical sessions where you can, you can feel where the technology is going. Actually, when I saw the conference program, I could see where the technology is going. And that probably makes my speech a little redundant. But anyway, I will try my best. Can you put the slides? So, although I am not expert on this, or there are still, the movement is going in the direction where people are in the course of becoming expert on this topic. But I thought I should take the topic on hype to talk about in the keynote speech. So I thought about why not IoT, technology and trends. I hope you all know a little about IoT, which is Internet of Things. So when we talk about Internet, when we talk about network, when we talk about individuals, the network of devices came into picture when a single device could not operate alone for the growing expectation from the device. So then we had a network. Then the network, we had many networks at many places. And particularly for the internet, probably, if I recall correct, there were islands in Hawaii where separate networks were operating. And then they had to be connected together. So that gave birth to the internet. So it acts similarly in the society. In the society also, we develop ourselves as a particular individual. When we are capable, we think we need more capability. So then we go to the network of people. And then when the network is also insufficient for ever-growing demand from the customers, from the service takers, ever-growing demand from our own ambitions, then we need internet of people. So it developed from network of computers to internet of computers, and now at this moment I think we see real internet of people. So when the social network platforms were created, those were created to bring real internet of people, not internet of corporates, not internet of information centers. So similarly, when we think about certain things operating for us, certain things which we operate, like the appliances, small appliance, like a microwave oven, it operates well and it acts good individually. But as we go on demanding the coordination of microwave operation with the, say, air condition. When I was in Japan, I couldn't turn on air conditioner and the microwave at the same time, or the rice cooker at the same time. It may sound funny, but I couldn't turn on. I had to make the cooperation by turning off the AC when I am using microwave. Okay? So right now, the demand is such that they should do these things by themselves. So if I am talking about my home or my office, these things which I am using, particularly driven by innovation in electrical and electronics, mechanical engineering, and so on, for having a coordinated orchestration. Now, maybe because we are too occupied with social media, maybe we are too occupied with other information, other network of people like Facebook, like YouTube. Now, it's our wish that You are the thing, but you cannot remain thing. You know, it's our wish. Now you have to orchestrate yourself. Now you have to coordinate between yourself, and then not only act like a network of things, but do things like Internet of Things. Okay? So, we are disappointed that our expectation is not made by individual. Our expectation is not made by a village or society, but with the Internet of Things, we are expecting that the things with their own network, with their own orchestration, with their own coordination, will act as an Internet of Things and meet our individual, community, national, and probably international, as well as beyond Earth life expectations. So, this thing, the Internet of Things, is under the hype. Probably we want to live lazy, or probably we want to live better. That's why we are trying to create, I think this is my thinking, which has been generated because I was interested with the keynote speech at this conference. Okay? It was not in my head before I took the stage. So it has made me to think that we are going to build the Internet of Things that will do what we think about by entrusting the devices, their interconnection, the communication between them, and their orchestration, probably with the help of another thing under hype, which is called artificial intelligence. So we are looking forward to that, I think, while delivering this keynote speech. So I will talk a little bit about IoT technology and trend because I am from technical background, and just try to comprehend what this system technically means to us. Okay? Philosophically, it is going to mean a lot for us in future, and it depends on where we are, whether we are in Nepal, in some place, whether we are in some other place. But let's see what, from the technical education point of view, what we may be looking at when we talk about Internet of Things. So we talked a lot about, various things before Internet of Things. For instance, we talked about wireless sensor networks. Dr. Anu Thapa is here. He worked a lot in wireless sensor networks and mobile ad hoc wireless sensor networks, where sensors could manage themselves, manage their own network, and coordinate for doing a coordinated sensing task. Then we talked about cyber physical system. We talked about SCADA, which was meant for real-time monitoring and control. Cyber physical system is still a big thing, which is being considered by electrical and electronics engineers, along with ICT people along with computer engineers for certain limited scope where you have control over the things you are going to operate. The other thing is M2M, which is machine type communication, which is talked about when we talked about new generation of cellular communications. And we also are talking about Web of Things, which is, interoperable device using protocols that is being used for computer to computer communication or people to people communication right now. So these are the terminologies, the terms which is used in conjunction with Internet of Things. So when we talk about Internet of Things, we are talking about coordinated operations in the field of like building automation, grid optimization, in power systems, in healthcare, in agriculture, in industrial environment, in mobility, transport, in retail like logistics, asset tracking, in public safety, environmental monitoring, also in the optimizing of the network, internet itself. So the world of internet, as I see from this BSAM research, is expanding and is being defined very specifically in various sectors. So it is encompassing wide spectrum, the whole rainbow of what could be in the field of probably automation, in the field of cooperated operation of things. Things means here the devices which has sensors, which has communication capability, which are driven by electrical and electronics, computer and communication technologies, but do really important thing for the people. So in every technology there is a hype cycle. Okay? When we talk about any technology, there is a hype cycle where the expectation grow exponentially when we start that, okay, this is our idea, this is the idea which we can work on, then our expectation grows very sharply to a peak, and then when we think about the reality, maybe we drop a bit, and then finally when we are in some sort of situation where we see that, okay, maybe it is too much ambitious and we cannot do a lot out of it, then if we start working very hard, then we reach a plateau of productivity. So with the IoT also, it's happening. Something came, it rose to the peak, and then people started thinking, okay, this may not be so useful, this may not be so good idea, or maybe I cannot do that. But it's not only me, it's not only my little network, it's now the internet of people who make every idea possible to go to productivity and then attain to the plateau of productivity. So in terms of Internet of Things, there are a lot of things coming, and all of them are moving through the cycle of hype and then trying to reach a plateau of productivity in some time. When we talk about Internet of Things system, then we talk first about applications, where we can apply it, what kind of architecture, what kind of topology they will take, and then we go to the technological aspect of it. Then we talk about sensors, data acquisition system, what kind of devices we should use, edge devices, whether we should use ESP32, whether we should use other kind of processors, Raspberry Pi, what kind of network interface we are going to have, and then we talk about the connectivity. Okay? So electrical and electronics engineers, they first think about devices, sensors, and building that module. And then we talk about connectivity, where we talk about data rate, bandwidth, what should be my throughput, whether it is burst kind of communication, whether it is continuous communication or what. Then we talk about latency, range, coverage, and mobility. And then we talk about penetration through walls and buildings, whether our devices are situated indoors or outdoors, with the visibility or not. We talk also about device density and scalability. As you know, we are not satisfied with 1. We want to go to 2, and then 2 to the power n. That is where we sometimes we fail, because we do not consider the scalability from the onset. So after connectivity, we also talk about services, where we talk about cloud support, edge computing, edge AI or cloud AI. We want to put AI in every sensible thing or every sensible solution right now, because it's going to help. And then we have challenges with monitoring and management, because the Internet of Things will generate data, and that has to be shown in dashboard, that has to be analyzed using data analytics, and then finally that has to decide where AI will come into picture. So the things will make their own decision in a coordinated manner using AI. Then when we think about putting a device for sensing, for doing actuation, for control applications, we want remote control. At the same time, we want autonomy in the device. So we want to fit certain things which can operate by itself, and at the same time, without going to them, we want them to behave as we desire. So there should be some sort of facility like zero touch operation. And when we have all these networks and all these things, then we have regulatory issues, regulatory and compliance issues, like spectrum use. If we are using wireless communication, interoperability, they should understand each other, whether they are supplied by one vendor or another vendor. Then we are talking about security, data security, privacy, and so many aspects. And then there is the challenge. There is the challenge of not only building the system that can, that can make people feel that their system, not only their system is safe, but they themselves are safe. In current, current media age, nothing is really secure. Nothing is really private. People talk about privacy a lot, but when we, in our private, talk about other people and their privacy, then the society also talks about that. No matter how good regulations you have, privacy breach will be there. And there will be hackers. So security becomes very essential when we talk about Internet of Things, because the things, they need to cooperate with themselves, they need to decide on themselves, and what if somebody hacks into it and tries to do things that are not desirable. And then Internet of Things will not be talked about in USA, will not be talked about only in Nepal. So people have different mindset, so people will have different kind of regulations. And of course, when we talk about device operating by itself, then device either should generate the power or device should have energy that will make the device operate for the entire life cycle of the device. So we put a battery, we charge once, and then when the device, other parts of the device is dead, then only the battery is dead, or when the battery is dead, the other parts of device are also about to die. When we talk about scale and importance of IoT devices, then we talk about two kind of IoT things. One is massive thing, one is critical IoT. So IoT is going to be massive because I listened to one podcast yesterday and I was surprised to hear that there are right now 18 billion IoT devices registered in internet, and it is going to be within 2 or 3 years, it is going to be 30 billion. So the number of IoT devices that is being used is growing exponentially, and we cannot stop it. It's going to rise and rise because all of us have the desire that things should operate, things should give me the service, and I should not be bothered about it. So, but still we are putting IoT devices in critical applications, not only massive but also critical applications. So we think, as I said earlier, there are autonomous systems, there are high value asset tracking, there are critical infrastructure which will be operating in future using IoT devices. So we should be very much careful about those devices, not only for their operation but also for their security and so on. So we electrical, electronics, computer, communication engineers more often think that our role, communication engineers more often think, I'm from both the background, but from the communication side, I think how the network operates, what kind of network we should provide to IoT. So the network operates like this. Most of the times we want a wireless network where there is a device domain and service provider infrastructure and the cloud service provided infrastructure in IoT. So these networks should operate for critical IoT, giving due value to the network reliability, latency and so on. For massive IoT, the network and cloud should operate in such a way that they can handle large set of data, and they can handle good data analytics, and they can handle artificial intelligence requirements. But for communication engineer, first thing first, they will think about what kind of network I should have for IoT. Right now, for IoT, the most used network is Wi-Fi, then LoRaWAN, cellular, Bluetooth, low energy, and then we talk about, when we talk about internet, truly global internet, then we talk about global area network as well. So these networks, as we see, as I can find, various options are there, like for local area network, Wi-Fi, Zigbee, Z-Wave, for wide area networks, LoRa, Sigfox, cellular, in cellular also narrowband, reduced capacity, LTE-M, and then since I teach satellite communications at Kathmandu University, I also think about satellite non-terrestrial network, which is called NTN NB-IoT. And then we can use personal area network for IoT, that is near field communication, and Bluetooth low energy. Also, industries, campuses like this may consider implementing private networks, which is private cellular or wireless network. And of course, we have a wired network as well, which we don't talk about much nowadays. So every IoT demands certain kind of connectivity, and those connectivities are listed here. You can refer to the slide or go to Bisham Research if you want to know more about it. Every connectivity has certain features, whether they can supply, they can address the challenges of data rate, power saving, coverage, reach availability of network, expansion of coverage, they can address the cost factor or not. You have several options for things to connect to the internet. So talking about LoRaWAN, which is one of the popular choices when we are thinking about small networks, then it is actually providing long range, it can operate in low power, low cost, it is secure by its standard protocol, it is standardized, many companies produce that, it also offers geolocation service, it also supports mobility and supports the high capacity. But for me, because I teach satellite communications, so I shall extend the concept to some satellite involving communication technology, which can provide services no matter whether you are in air, whether you are in sea, whether you are in remote or rural area, whether you are in urban area. Of course, in urban area we prefer cellular, but IoT services can be provided by satellite also. So talking about satellite IoT connectivity, we have NTN NB-IoT satellite connectivity or proprietary satellite IoT. Here in these slides, you can see the comparison, and of course you can refer to groundcontrol.com or biosat.com for more knowledge about it. Why I talk about satellite? Because satellite is all around us, and if we are not indoors, satellite will see us. So satellite will see the things as well, and in many cases satellite connectivity is requirement where you have, for example, remote industrial operations, maritime, offshore connectivity, in disaster response, emergency services, critical infrastructure monitoring, particularly wide area infrastructures like power grid, global supply chain and logistics, where you have to track your consignment from United States to Nepal at each and every moment, agricultural monitoring, large area agriculture, mining, and military and defense communications. So talking about satellite service providers, Iridium is one of the provider of satellite IoT services. Global Star is another one. And you can also opt for Thuraya or Inmarsat if they provide the service. As I already told about, satellite can provide services where it is not so possible with cellular or terrestrial communication, which encompasses personal communication, global government communications, maritime communication, polar communication, transportation, logistics and delivery, government services, emergency services, autonomous systems like network of UAVs, industrial systems, large industry, aviation, research and energy. Satellite IoT in Nepal, I could see two cases. One is Iridium use case, which is installed by University of Leeds, which monitors the glacier at 6,000 meters in Everest region. This uses, as I said, Iridium satellite communication. And the another one uses Thuraya IoT M2M, which uses for monitoring, environment monitoring, hydropower and hydrology monitoring. The local client is real-time solutions, and the product is Thuraya M2M communications. If we talk about satellite service provider, communication service provider in IoT, Viasat, you can see here they provide NB-NTN service, that is narrowband non-terrestrial network. They also provide IoT Nano, IoT Select, MSS, that is mobile satellite service, and IoT Pro, BZN, that is broadband global area network, M2M. So all these operate in L-band and give facility for various applications. As I said earlier, that having things is the first desire, but when we have our desire fulfilled, then there is headaches for us, and that headaches are called challenges. Okay, so there is challenge in managing and monitoring. As I said earlier, there is challenge in security, there is challenge of having autonomy in that system, and there is challenge related to the protocols in which the systems operate. So if you cannot operate the system universally, then it is going to be very difficult. Like people will speak several languages, but when we have to interoperate, we have opted for English. So similarly, having said that, not everyone opts for English probably anymore, because you can right now communicate with the other languages with AI assistance. So the things has evolved. So interoperability previously was single solution, but right now you have multi-protocol solution as well. Similarly, with the devices, also you want something similar, multi-protocol supporting. One of the things in cellular communication, when we use cellular communication or satellite communication for IoT, we'll talk about eSIM and iSIM. So we had SIM, which was not programmable. Now we want SIM, which is programmable, not only programmable, but also programmable with zero touch. Network can program itself. Network can, configure itself when you switch the network. So for this, we have something called remote SIM provisioning, and which demands eSIM and iSIM. Probably newer IoT devices will use eSIM and iSIM, and those eSIM and iSIM will be supported by every protocols, whether you use Bluetooth, whether you use Wi-Fi, whether you use another kind of system, satellite, whether you use cellular. I already said something about protocols and security concerns. I already said something about regulatory challenges, because the regulatory control of IoT is going to be very difficult, because by the name it is going to be distributed in several geographical area in so many numbers that it will be very difficult to track. About protocols, we have a lot of protocols can be considered for IoT. The most popular one right now is MQTT, while you can also opt for other protocols also. So with IoT, the challenge in monitoring, service providing is being taken quite seriously by big companies, where they provide service in one of the three models: infrastructure as a service, or platform as a service, software as a service. And if we are doing some DIY projects for a small home automation and so on, we can do other kind of model as well, taking some cloud-based solution. So this table presents a kind of comparison between different kind of services and the different kind of services that is being provided by big companies. As you see, the IoT is going to become a big business for every large companies we think about, like Microsoft, like Amazon Web Service, like Google Cloud, and so on. Finally, I would like to present some concluding remarks, actually which is generated by Copilot and edited by me. So I asked, naturally, when catching the trend, I asked Copilot, what should be my concluding remarks if I'm going to talk about IoT technology and trend. So it says, edited by me of course, the Internet of Things is no longer a futuristic concept. It is the backbone of today's connected world, driving efficiency, innovation, and new opportunities. There is a large opportunity, large challenge in IoT right now, because the Internet of computers and the Internet of people is matured. Internet of Things is just born, not matured even in very developed countries. So there is the possibility you can take the ambition and move to the height and then fall to the bottom and finally find a way to go to the plateau of productivity. It is not that you are going to go to the top and remain there. Beyond devices, connectivity, and data analytics, IoT is about empowering people. As I said earlier, either we are lazy, or either we want to do things, we don't want to do the things we used to do in past, we want to do the things for the future, and the things which were being done by us in the past should be assigned to the thing. So even the roti maker, have you seen the new ad of roti maker? You put water here, you put flour here, and the roti comes out of the machine. So if it is IoT machine, then we can think about, the roti would be coming when we want, and the roti would be coming in the nicest way we want it. As innovators, we are learners, and our learning objective is to become innovators. Okay? And then, first objective is we want to be innovator. And then, if we can't be innovator, we want to go to service. Provide the service to the people. Innovation means trying a unique service for the people by yourself. So that is what we are aiming for. right now when we are a student. But when you are retiring like me, then innovation means trying to get out of the business of other people. So how to get not involved is also innovation. But that is not for you. For you, it's innovation and learning is for trying to make something useful that has your trademark. And then we go to service. So as an innovator and learner, it is our responsibility to harness IoT for meaningful progress towards building solutions that are sustainable, inclusive, and secure. That means be responsible while doing innovation. The trends we see today like massive IoT, edge computing, interoperability, AI integration are only the beginning. The real transformation lies ahead. As I said earlier, the Internet of Things is just being born. It's a long time to go and long time to see. And IoT is not just about connecting things, it's about connecting possibilities. So with these words and a final mythological thought, we always say God is watching us. We always say God is watching us. We are living being, not thing. But for God, we maybe think we have a lot of sensors. What if God is doing our data analytics over there and we don't know actually we are sending? We send very little of radio waves from ourselves. You know, our heart we can monitor by monitoring electrical signals. So electronics, probably we can think whether we are also seeing and God is monitoring us like Google. So with the thought, I thank you for your time and listening to me and wish you all the best in your journey towards IoT. Thank you very much.
Thank you very much, sir, for your insightful and inspiring session. We truly appreciate your valuable time and contribution to this conference. Now, marking the conclusion of the keynote session, I would like to invite the principal of Khopa Engineering College, Engineer Sujan Maka, sir, to the stage to kindly present a small token of appreciation to our speaker, Professor Bhupendra Bimal Chetri. Let's give them a huge round of applause. Once again, thank you very much, sir, for being with us here today and sharing your valuable insights. Now, we will have a short tea break of 15 minutes, and after the tea break, the technical sessions will be conducted in parallel venues. The electronics technical session will be held in Hall 2. All the electronics presentators and participants are kindly requested to proceed to Hall 2 after the break. The electrical technical session will be held in Hall 3. All the electrics presentators and participants are kindly requested to proceed to Hall 3 after the break. And the computer technical session will continue here in Hall 1 itself. All the computer presentators and participants are requested to remain in this hall after the tea break. Please reassemble promptly after 15 minutes. Thank you everyone and enjoy your tea. to present their original work, share innovative ideas, and engage in scholarly discussions. For this conference, we have a total of 12 research papers in the computer engineering field for presentation. To ensure smooth management and meaningful discussion, the technical presentations have been divided into 2 slots with 6 papers scheduled in each slot. Each accepted paper has been assigned a unique paper ID for identification and coordination. We now begin the technical session slot 1, where 6 research teams will present their work. Each presenting team will be allotted 10 minutes for presentation, and a warning bell will ring at 8 minutes, and a final bell will ring at 10 minutes. A 5-minute Q&A session will be done, that is led by our session chair. Now, please join me in inviting our session chair for the technical session slot 1, Dr. Bipun Manpati, as I hand over the technical sessions to him. Dr. Bipun Manpati is a senior assistant professor and a chief of AI Research Center at the Advanced College of Engineering and Management, affiliated with Tribhuvan University. He received his doctorate in engineering and master's in engineering and telecommunication engineering from the Asian Institute of Technology, Thailand, and his bachelor's degree from the Nepal College of Information Technology. He was a C2F postdoctoral fellow at Chulalongkorn University and a senior research associate at Glodor Inc. Japan. His research focuses on wireless communications, signal processing, and machine learning. Please welcome him with a huge round of applause. Now I'd like to hand over the session to our session chair.
Thank you. So I would like to begin today's session. So the first paper is from Jayadev Tripathi. I would like to welcome him for this presentation.
Respected session chairs, teachers, and fellow participants, and everyone present here. Good morning. I am Jayadev Tripathi, and today I will be presenting my research topic or research project entitled Fallacy-Aware Argument Analysis and Improvement Using Structured Argumentation and Large Language Models. After the presentation, I will make it sure I will not use any logical fallacies during the presentation, and even if I does, I will make it sure you will be able to detect it. Good morning, everyone. Let me begin with my presentation. This topic, Fallacy-Aware Argument Analysis and Improvement Using Structured Argumentation and Large Language Model. This work is based in the integration of the large language models with the argumentation frameworks like the Tolmin models. So begin with the presentation outlines first. First I will include the introduction, the problem statement, then methodology, then finally we will be discussing the result and discussions, then conclusion and the final remarks. So begin with the introduction. Logical fallacies. Have you ever heard this term before, logical fallacies? And let me begin with it. Logical fallacies, though you might haven't heard about the terms before, it is mostly engaged in the everyday debates or every arguments we are hearing or we are facing. And we probably ourselves might be using it to win the argument or to present our ideas. Logical fallacies, they are generally the errors in reasoning that makes arguments appear convincing but are logically flawed. They are common in social media debates, political arguments, and everyday discussions. Large language models, while they have significantly improved throughout and are powerful, but they often overlook these fallacies. Some fallacies include ad hominem. This means attacking the person instead of the argument. Like suppose we generally used to talk, look at our teacher, he is so fat, how can be the teacher, right? That makes no sense completely, because the person appearance or looks that isn't included with his professionalism. Further, faulty generalization, that is drawing conclusion from the insufficient evidence. False causality, just blaming the term we most oftenly use, that he is the Panauti. The team loses the match, they say the Prime Minister congratulates them. That is the Panauti. Looks like fun, but deeply if we go through it, that is the term logical fallacy, and this such particular case is false causality. Appeal to emotion, emotionally overpowering the argument. And further, the project is inspired by the need to bridge the alignment gap between AI-generated responses and human preferences for logical soundness. This research introduces a system that detects structures and improves argument to mitigate such risk. By combining formal logic with generative AI, this system enhances reasoning capabilities and serves as a tool for debate causing, education, and professional or technical writings. The problem statement. Identifying the flawed arguments, it is basically challenging for the normal individuals who lack formal training regarding logic and argumentation. The current large language models often generate fallacious arguments such as faulty generalization or circular reasoning without explicit guidance. And there is significant research gap in how structured argumentation tools like the Tolman models can be effectively integrated with LLMs for real-time argument refinement. Further, we might have heard about the Grammarly tool, right? We often use it to correct our grammatical errors. That is, the grammatical errors including the spellings, logic, sentence structures, but not the logic. So, and further, existing data sets often focus only on detection rather than holistic improvement of the structure of the arguments. The methodology. This system employs a multi-stage pipeline consisting classification, structuring, and reasoning. The first step, fallacy detection. Using a fine-tuned transformer models. The second phase, argument structuring based on Tolman model of argumentation. Step 3, refinement using adaptive dual mode reasoning using a large language model. And here with the block diagram, the first users will give the input argument, and the pre-trained fallacy detection model, Electra, is used to classify the logical fallacy present in the argument, and then structuring or breaking down the argument into key Tolman elements, and finally generating the refined argument using the Gemma model. So the first user argument, it is the user provided reasoning that system will analyze. The first component is fallacy detection. The detection phase utilizes a pre-trained Electra-based transformer model which was trained on about 2500 data across 13 distinct fallacy types. The logic data set and the pre-trained Electra-based classifier used in this study was introduced by Jane et al. In EMNLP 2024, which achieved 58.77% F1 score, 55.25% precision, and 63.67% recall, and 47.67% accuracy in fallacy detection among those 13 categories. The second component, argument structuring. This is the main aspect or the heart of this study, the Tolman model. Arguments are structured using the Tolman models to identify core components, claim, evidence, and warrant, and the supporting three components, backing, qualifier, and rebuttal. It is the philosophical argumentation framework proposed by Stephen Tolman. Looking at the scientific argumentation, this scientific argumentation Tolman framework, there are key 6 elements: the data or the evidence, and the claim, the conclusion. What the argument is trying to claim, what it is making the claim, the data, what supports that claim, and the qualifier, what makes that data qualified to prove that claim. And further, rebuttal, that is, has the argument tackle the counter responses. Backing, what backs the warrant, what backs the qualifier. And the warrant explains how the data leads to the claim. Fallacies often occur where the reasoning link is weak, evidence is emotional, claims are obsolete, and counter arguments are ignored. The third component, refined argument generation. After the detection of the fallacy and breaking down the components, the finally refined arguments is generated using the JEMA model. And the 2 operational modes are implemented. Support mode, that is for the user. Support mode, the system will generally analyzes the user argument and then gives the gentle breakdown of the argument and finally generate the refined version. And the defense mode, it is generally the tool for the analysis and users analysis of the user's resistance to the fallacy. And prompting strategy, zero-shot prompting is used for the refinement of the prompt, for the refinement of the arguments. And the results and discussions. The empirical observation indicates shows some significant reduction in fallacy prevalence after the system-assisted revision. The integration of the Tolman structure helped users identify missing warrants, leading to more coherent reasoning. Support mode strengthens arguments using Tolman-based refinement, while defense mode stress tests reasoning by generating controlled fallacy-based counter-arguments. And a few examples. Input argument. J.K. Rowling is a wonderful writer because she writes so well. Yeah? J.K. Rowling is a wonderful writer, we know, but how they are presenting it is because she writes so well. It is not the general way to say someone writes so well means she is a better writer. So detected fallacy is ad populum because majority claims that she is the best writer. Tolman components claim, what is claimed here? J.K. Rowling is a wonderful writer. Data, she writes so well. Yeah. Warrant, good writing. Okay, thank you.
Thank you, Jayadev Tripathi, for your wonderful presentation on detecting fallacy. Right. So first of all, I would like to have the audience, if they have any questions. Any from the delegates? Okay, just a few questions from my side as a session chair. So, yeah, thank you for this presentation on fallacy detection. So, it is quite interesting to see that like you have developed an integrated system to detect fallacy.
Yes, sir.
So, my first question is regarding the evaluation. So, in the first step, like you have mentioned, you have a 58% of F1 score, right, from the paper, the first step of your fallacy detection. So, in case of like false positives or false negatives, like 58% F1 score means there can be some false positives, right? There can be some false negatives. So how does your system actually handle this kind of scenarios?
Okay, the first thing is this study implements the model from the existing literature, and to handle such scenarios we can introduce the context-aware models. Like in that paper, the researcher has worked on generating the data set. He has worked on several data sets from the Reddits and educational platforms. So we can further work regarding the model refinement using such argumentation framework for that purpose.
Okay, so your core novelty of your paper lies in this dual mode integration, right?
Integration of the argumentation framework.
So I think to better to help audience also to better understand, can you actually go through a process like what if you do not have your Tolmin model?
Sir.
So if there is absence of the Tolmin model, I guess, right? What will happen and what is the importance of this Tolmin model?
Yeah, so there is significant work done in improving the sound logical arguments from the LLM despite using the Tolmin model. But in such cases, after reviewing the presence of the fallacies is still in such scenarios, the heart of this research, the Tolmin models, simply the main use cases of this Tolmin model is the breakdown of the argument into those 6 components and fulfilling each.
My question is what if you do not have you have a user generated text, you do not create a tooling structure and you run the LLM through your support mode or defense mode. In that case, what output will you expect? How good output will you expect as compared to having your Tolmin structure in between those two?
Sir, I haven't gone through that, but I believe there will still be the relevant presence of the persistent fallacies.
Okay. So for my last question, okay, it's related to some generalizability. So you have used your overall the fallacy detection module at the first part that is trained on logic dataset, right?
Yes, sir.
So these datasets they all contain well-formed examples, right, about the fallacy and its types. But like you mentioned in your introduction part in slide number 3, that these logical fallacies are common in social media debates, right? So have you also worked on those social media dataset, or just you have only used the paper number 1 model for detecting fallacies?
Yeah, I got motivated to enter into this context after several samples from the social media's conversations.
So in the actual real life social media, right, there will be like kind of a noisy data, right, as compared to the data set that the first part of your logic fallacy has been trained on, the paper 1, they have trained it on logic data set. So what if I use your system on actual social media text inputs? What will be the performance regarding that?
In this same pipeline?
Yeah.
So,
but the data set is now noisy, right?
Yes, sir.
And it is from the social media. It is not like well formed in case of like logic data set that your fallacy detection module has been trained.
That logic data set, it itself is from the Reddit conversations and similar educational frameworks.
Okay. Okay, thank you. That is all.
You're welcome, sir.
Every day, thousands of new AI research papers are published, and the model you are relying on are getting dumber and dumber for the context. And what's the solution for it is the Scholar Mind, a continuous learning for research assistant. The challenge of static AI in rapidly growing scientific field. Daily, thousands and thousands of research papers are getting published. Static large language models are outdated quickly. Fine-tuning risk catastrophic forgetting, and the solution is not available to every one of us in this room. So we present Scholar Mind, our contribution, a multi-agent architecture, autonomous pipeline for scraping, validating research papers, curating high-value research data without human intervention or autonomously, CLORA-based updates, efficient 4-bit quantization, enabling perpetual model evolution on consumer-grade hardware, a dual memory system for better performance, and a Bayesian optimization which gives 40% stability across sequential training cycles. The problem statement. New discoveries paper I published daily and static models get outdated instantly. The catastrophic forgetting is another issue, and the static RAG limitation is, and the resource barriers. The resource part, state-of-the-art continuous learning often requires massive VRAM clusters and making it inaccessible to independent researchers. The autonomy app, current raw research method still require constant human in the loop supervision for data curation and tuning. The solution is a way to enable perpetual model evolution on consumer-grade hardware without manual intervention. The methodology, we built an architecture of agents that autonomously extract the paper from archive for the latest domain-specific publication, or validation agent which improves the training data by 84% by keyword filtering, and the curation agent which automatically extracts key insight and previous high-quality instruction tuning pairs for sequential CLORA update cycles. Methodology, we have used efficient adaptation CLORA for it, and for 4-bit normal float quantization, we have done it in 2GB VRAM, and using Bayesian optimization, using which we have gained 40% improvement in convergence stability. Here we have freeze. Here we have only kept 0.47% of the modus parameter trainable, and everything others are freezed. And using that we have trained and experimented at for 2 conductors. We have conducted 56 autonomous training cycle without human intervention in the loop. It has 8400 research papers proceed. And from our static baseline, it has 72% relative improvement, and the data quality has been stabilized by 84% by heavy keyword filtering from the papers. And the main issue is stability, and we have gained 40% stability gain using Bayesian hyperparameter optimization. Conclusion and feature, autonomous evolution, square mind inverse model to save fever by learning from high value research without human intervention. Optimized for consumer grade hardware, requiring only 2 GB VRAM perpetual updates. Achieved a 72% improvement in the auto-observation function across 56 autonomous cycle and feature direction. Scaling square mind to evolve across multiple distributed nodes for collective knowledge sharing. Improve the model's ability to synthesize and finding across different research domains. And full code base and training logs are available on GitHub to support community-driven reproducibility, and everybody can gain access to it via GitHub. And this difference. Thank you.
Thank you, Ashish Pandey, for your wonderful presentation on continuous learning for research assistant, a multi-agent approach. I really like your work. So yeah, first of all, I would like to go from the audience if they have any questions. Still no questions? Okay, then I think it's just me asking the questions. So yeah, just 2 to 3 queries that I have, like for even audience to understand the work that you have carried out. So actually, my first question is like, let's say you have 50 papers on a particular, let's say on a particular topic that you have done this system, right? And let's say in that particular topic, a kind of new revolution comes out. 50 next paper, let's say. And suppose if the user wants, right, after 3 months, let's say, after 3 months, your database might be updated, your weights of the model might be updated. After 3 months, if I query about a particular topic that was, your model went through some training, right, 3 months ago. So how will your model consult the persistent vector right? How will you model how will you force your model to consult the percentage vector rather than relying on its updated parameters?
Yes, that's a very nice question. Our system has a permanent memory system that stores embeddings of every paper that has ever passed. So, say we trained 50 papers in one epoch, or say we trained 50 papers at first after they were new, and after next 3 months, suppose we want to know there are other new papers, we want to know what new findings or what new papers have arrived, then the system has already previously stored a cache of the embeddings. So that cache is loaded again to the similarity measure system that we have, and then new 50 papers, each papers are checked with the cache embeddings, and then we can figure out.
So it is that cache embedding that allows your model to exactly that to retrieve the earlier knowledge.
Yes,
Right.
exactly.
Okay. Oh, thank you. The second question is from your result section. So you have mentioned like there is a 72% relative improvement, right, in your
Yes.
composite objective function.
Yes, exactly.
So could you decompose that into like how much was the gain from perplexity? How much gain did you arrive from the BLU score? Have you decomposed them? And
We actually composed that by combining these three scores.
okay, so you do not have actually how much gain is from the perplexity, how much gain, so you just combined them, right?
Yeah, we combined them, we scaled them into a similar scale. Rogue and Blue are all in a similar scale, 0 to 1. Perplexity, however, we had to run a log function in it to bring it into range, and then we combined them into a overall score, and that's how we got 72% improvement in our system.
Okay, my last question. So you have mentioned in your abstract, right, about regarding the reinforcement from the source paper as a limitation in your abstract, right? So, it's just a future work question. Like for like self-evolving and autonomous system, right? So you have a certain this potential bias refinement, right? In future, like what would be your research direction regarding how to remove this kind of things, limitations? Do you have any idea on that?
To remove what exactly, sir?
The limitations that you have mentioned, right? Limitation of potential bias reinforcement from the source paper.
Okay.
While current limitations include potential bias reinforcement from source paper, our framework offers a viable path for decentralized.
For that, what we are currently already doing is we are training a custom model from scratch just for this purpose. And then currently we are using Phi 3 model, and the model that we are developing from scratch, that it's a 700 million parameter model, and after that, once the model is developed and trained and everything, then we go into the distillation loop, and using that distillation loop, between two models, there will be a conversation using agent so that it bridges the gap.
Okay. Okay, that is all. Thank you for your presentation, Asim.
Thank you so much, everyone.
So, for the next presentation, I would like to welcome Tuyal Shrestha for his paper titled Nepali Grammatical Error Correction. Please welcome.
Good morning, sessions here, delegates and fellow participants. Today, on the behalf of my teammates, Rohit Baskola, Saman Gosai, Sumit Lasio, and myself, Tuyal Shrestha, I am going to explain about our project, Nepali Grammatical Error Correction. This is the presentation outlines for today's presentation. Let's start with the introduction. Grammatical error correction, or GEC in short, which is widely used, focuses on automatically detecting and correcting grammatical errors and spelling errors in a sentence. In high resources like English, GEC systems have achieved a very good performance using large dataset and well-established benchmarks, but Nepali or low resource language remains underexplored with very limited dataset and no proper benchmarks. So for this task, we have explored a multilingual pretend transformer MT5 to solve the grammatical errors. Our project also has a very good scope. It can be used in almost any areas wherever Nepali text is written in a computer. It can be used to support education, communication, and enhance user experience in various apps and websites. So the problem statement, Nepali GEC remains an underexplored area due to lack of large data set and standardized benchmarks. Most GEC systems focus on IRISOS language, but Nepali is limited with automated writing support. Manual correction of Nepali is time consuming and error prone, especially for learners, students, and digital content creators. And it is also unclear how well multilingual pretend models such as MT5 perform on such tasks. So this is our methodology. This is the block diagram, and first we have created our own synthetic Nepali error dataset. Then the dataset was preprocessed and tokenized. Then we use MT5 for training the data. Then the model outputted the corrected sentence, and we evaluated the model based on those sentences. Let's understand more on those blocks. First, we created our own synthetic Nepali error dataset. We created around 1 million pairs of correct and incorrect sentences using rule-based error generation and bot-style masking. We use the IRIS dataset for obtaining the clean sentence and use rule-based error generation and bot-style masking to generate errors. We also fine-tune NepBotter for Nepali POS tagging or Nepali part of speech tagging to help us guide in masking and create meaningful errors. In our dataset, there are mainly 4 types of errors: morphological, structural, orthographic, and semantic errors. And this was the error distribution in our dataset. The multi-error here refers to the more than one errors within a sentence and is very crucial, as normal human errors does not include only one error within a sentence. And then we pre-process our dataset. We clean the text by removing noise, duplication, and formatting inconsistencies. Then the tokenization was done using the MT5 model's own tokenizer sentence piece. Then we use data loader for efficient batching and training. Then we train this dataset on the MT5 model. MT5 model is basically multilingual T5, and T5 stands for text-to-text transformer, which deals with problems involving input text and output also text. So and MT5 is trained on around 101 languages, including Nepali. So this is a very good model to solve our Nepali GEC. And after the model was trained and fine-tuned, then the model generated 3 correcting sentences. The model outputted candidate correct sentence, and we use beam source along with a re-ranker to generate the best possible correct sentence. As beam source always doesn't generate the correct sentence in the top 1 candidate, so we also use re-ranker to select the best possible answer. And this is also our training strategy. We trained 3 variations of MT5: MT5 small, base, and MT5 large. And we trained for our 26,000 steps. We use ADAMW optimizer, and we started with learning rate of 5 to 10 to the power minus 4. And we use cross-interpret loss and evaluated on this matrix. We also use LoRa on MT5 large as it contained very used training parameters around 1.2 billion, so which helps to reduce memory and training cost. So the evaluation matrix we use were precision, recall. Precision basically represents how many edits or how many changes in the sentence that the model were made that were actually correct, and recall represents how many of the actual edits needed within the sentence is made by the model. And we also use F0.5, which is a standard metric in other IRISOS languages. This F0.5 is basically F score of precision and recall using the weight of 0.5, which weights precision 2 times higher than the recall, as precision is ideally more important than recall in GEC tasks. And we also use GLUE, which is another standard metric for GEC tasks. It calculates the n-gram overlap between hypothesis and reference. And we also use the final metric, exact match. This is a very harsh metric, and it measures if the output sentence by the model is the same or not to the reference output or the correct output. And these were the results on the 3 models. So we created a uniform test data set and tested these all three models. The MD5 model obtained the best score on glue and exact maths, along with slightly better scores on recall. But the MD5 Lars obtained overall better score on F0.5 and precision. So the higher value of precision means that the MD5 Lars model was the corrections that the MD5 Lars model made were more reliable and accurate, whereas the MD5 base model with a slightly better recall score meant that the MD5 base model made more of the required errors. And this is a graph between F0.5 scores and the error types within our test data set. This graph is for the MD5 Lars model as it obtained the highest F0.5 scores. Our model obtained the best F0.5 scores on the auxiliary types of errors, and whereas it obtained low scores on structure and power planes errors with 0 F0.5 scores on honorific errors. The MD5 Lars model had high precision but low recall, which means that the errors that it made were reliable, but it also missed errors. So it had a conservative type of behavior, which is common in low resource GEC tasks. And the model also performed based on auxiliary while it struggled in power planes, so indicating that it had slight difficulty in capturing broader sentence context. And the overall exact mass was 27.5%, while glue was 54.07 for the MD5 Lars model, indicating that our model had moderate sentence level performance, but the recall still needs to be improved. And conclusion, overall our Nepali grammatical error correction was trained and performed on the MD5 small, Lars and base models using our own synthetic Nepali GEC dataset and a uniform test dataset. Among the models, MD5 Lars obtained the best overall F0.5 scores. This project can be a good good step in the GEC tasks and for further works. And the future works that came down, we can explore a hybrid system that combines neural models with rule-based methods to capture better Nepali grammatical patterns. We can also investigate sequence tagging approaches that have been widely used in high-resource languages like English and have outperformed many other models. We can also develop a high-quality gold dataset, which is basically a manually created and manually verified dataset that has errors more natural to the human, that has errors which are more like the errors made by the humans, and that can be used for fine-tuning. And we can also standardize evaluation strategy for Nepali GEC to more accurately compare the models at error span level, including operations like replacement, insertion, and deletion. And these were the references that we used for our project. Thank you.
Thank you to all and the team for your presentation on developing a multilingual model for correcting Nepali grammar and creating a huge synthetic data set. So first of all, I would like to go again with the audience for if they have any questions. Please feel free to ask any questions.
Okay, thank you for your presentation. How did you prepare Nepali error data? Is it open source now?
It is not currently open source, but if we request it, we can make it open source. And we created a data set by using various methods like RTT method, round trip translation method, and also BERT that are available. Not standard BERT, but not benchmarked method, but we used what we could.
Okay, thank you.
Wonderful presentation. But instead of using pre-trained models completely trained in Nepali like NEPBERTA, why have you opted for models like T5, which is multilingual model and performs poorly on Nepali language?
So for using BERT models like NEPBERTA, the data set that must be used is very different. The data set must be sequence tagging data set. So
to create such data set, it is quite hard and manually time consuming. So we used simple data set like incorrect and correct pair data set. Okay, thank you.
Does that answer your questions? Is it okay? Okay. So yeah, I have a few questions. Thank you. So my first question is regarding the data set, right, in the methodology part. So you have actually created totally a huge amount of synthetic data set. And yeah, synthetic data set is not by means any ideal. So did you actually do any error pattern analysis on your synthetic data? And let's say, and some 200 samples of actual social media data set that you can collect?
We only use the ICE data set.
Yeah, I just want to know, like, whether did you manually also collect some data set to determine the error patterns in your synthetic data set? And if you have, I saw one slide in which you have mentioned that you have manually also collected some data set, right?
So we manually created data set was for test set actually.
Okay.
Synthetic data set was for training.
Okay, so for test set you use the manually collected data set,
Yes.
and for only training purpose you did that. Okay. So so what was the motivation behind using beam search as compared to like greedy search? Why did you use beam search as compared to greedy output?
Because while using greedy output, the model outputted only one output, and it was not always the best. And while using beam source, there were like multiple candidates that could be correct, and sometimes the model outputted the correct sentence in like the thought-based result. So we used the beam source and used re-ranker as well to output the best answer.
Okay. So so for your comparison, right? Did you only compare with? Do you have any baseline comparison model that you compare with?
In Nepali, currently there is no research that has been done like this, and the metrics are also not standardized. One paper used blue, and which is not good for
I mean
GEC.
the baseline regarding your model. So you have used T5 model, right?
Yes.
So did you do the same simulation on some other existing baseline models, like let's say MBAT model, and then check whether your T5 model is actually performing better as compared to some other existing MBAT models? In that scenario, in that case,
We have also tested on MBAT model, but the work is
how was the
ongoing.
performance on that?
The glue was slightly better, but the F5 was nearly identical.
Okay,
work is
you have shown the result of that also in your paper, right?
Only MT5.
Only T5. I think it's just a constructive feedback, if you could have improved that. So my last question, so your dataset is still not open source, right? You haven't made it open source, right?
We don't know if it is quality full enough to open source. If we can, it can be checked by export or export of grammar, Nepali grammar, then we can open source it after checking.
So you haven't done any quality checks on your synthetic dataset?
Yeah, we have manually done, but we are not experts in Nepali grammar. So we would like to open source after it has been checked by expert in Nepali grammar.
Okay. So training for 2 million, do you have any curve that suggests, okay, your learning is complete? Why did you only train for 2 epochs for such a huge data set, like 1 million?
For MT5 models, both encoder and decoder is used, and the training time is very large for such models. So, and after training 2 epochs, the curve also not progressed. Error was not decreasing.
Okay, after 2 epoch, error was not decreasing, so that is why you okay, thank you. Thank you for your presentation. So, For the next presentation, I would like to welcome Roman Kosicua for his paper titled Bidirectional Nepali-English Neural Machine Translation Using Attention-Based Transformer. Please welcome.
Hello. So imagine you're handling a vital health information in computer and some machine translation app has mangled the dataset, so it potentially costs lives. That's not good, right? So Nepali that is the harsh reality for many low resource languages like Nepali. So good morning everybody. Thank you for joining us at National Conference on Computer, Electronics and Communication Engineering. I am Nasim Deola, along with my team, Roman Kosicua, are excited to present our project on bidirectional Nepali-English neural machine translation. So this project was handled on Khopa College of Engineering. So we would like to proceed our presentation on six parts. Firstly, introduction, then project problem statement, methodology, result and discussion, conclusion and future works, and references. So machine translation. So what is machine translation? Machine translation is the core task of NLP which seamlessly translates from one language to another. So in context of Nepal is a low resource linguistic landscape. So there is low resource linguistic landscape for Nepal, such that filling the gap where mainstream translation tools often fail in accuracy and poorly capture local nuances. So for filling up that gap, we present our translation app which provides a relevance for vast domain like health, government services. So problem statement. Imagine some transition in governmental policy are different such that it causes confusion. So same happens in problem statement. Like for a single source language, there could be multiple valid transition which can complicate our standard NMT training. Similarly, there are limited high-quality parallel corpora, meaning correct bilingual English and Nepali dataset are very scarce. Similarly, Nepali and English follows different sources, like Nepali is using subject-object-verb, meaning ma kitab padchu, which directly translates I book read, but in English it uses subject-verb-object, meaning I am reading book. So following that, we are following a structural working flow which utilizes collection of parallel corpora, then pre-processing them and training model and fine-tuning them such that we are able to train full model and save and evaluate the model. So for that, we will be collecting parallel corpora. Similarly, we have collected 1.78 million sentence pairs from various sources. The sources can be seen as GNOME, KDE, Ubuntu. Like similarly, different law commission sources and Bible and all. Similarly, after collecting those datasets, we perform pre-processing. So we have performed pre-processing where we remove the noises, tokenize them, and padding them. So similarly, for that, we perform rigorous pre-processing where we cleaned the dataset which contains emoji and empty lines. We removed those, and we also removed character repetitions such as BB and all, which doesn't make sense. And similarly, we perform subword tokenization, making sure that the dataset is usable for our model. Then after that, we feed that dataset into our transformer architecture. So we are using transformer architecture followed by Vaswani et al. So here we can see we are using encoder-decoder transformer with multi-head attention. So we have trained our model on following configuration, like we have prepared the model such that it is able to take batch size of 32 with vocab of 32,768 and with layers of 5-layer transformer having 8 attention head and 512 embeddings. We also perform level smoothing and 1-cycle LR such that the data are regularized and the dropout rate is reduced to 0.2. So to handle forward slides, I would like to present Roman.
So talking about our results, the initial hardware we trained on were NVIDIA GeForce RTX 2080 Ti with 11 GB VRAM with the initial runs for 12 hours. Initially, it was quite difficult to make the balance between GPU utilization and memory footprint. So in order to efficiently train our model, we use various efficient methods like using early stopping with a counter of 5 and the pipelining these with the dynamic positional embedding and thus compile with mixed optimization. So we trained our whole pipeline in 3 phases. With early phases, we trained only 30 pairs where we managed to test only the pipeline. And then at the phase 2, we scaled to 300K pairs where whole flow was maintained. And at the last phase, that is full phase, third phase, we trained whole data set with a total of 32 experimentals. Moving to the next slide. So since the hardware was the main constraint, we solved it with using the previous pipelining methods. With this, we achieved the efficiency of 34% from memory usage of 8.5 to 6 GB and training speed improvement, that is 2 times. So let's discuss about our charts. These are our training and loss chart. Here we can see in the loss chart, the model is slightly declined at up to epoch 10 and it stabilizes from onwards. Here we can see the loss stops at around 38 epochs. It is due to patience counter of 5. And similarly for the accuracy chart. So this is the main highlight of the presentation. We can see the comparison table. These are the first and second are trained on the initial 150K pairs, and the third and fourth models are compared to the standard Flores test, dev test, and test provided by the Flores. We can see our model has surpassed the previous score of 20.76 with an improvement of 21.59 from dev test and to 21.23 to test. And for the English to Nepali, we have achieved a 9.49 blue, which is a slight improvement from 9.42. This test our model has improved a bit. So here are the examples of our model. You can see the model is contextually right for both English and Nepali. And moving to the conclusion, so main key achievements was the state-of-the-art bidirectional Flores results for the Nepali English translation, and future work includes the training on larger dataset and domain-specific datasets, generating additional training data through iterative back translation. So these are our references. You can see. Thank you.
Thank you, Roman and your friend, for the presentation regarding Nepali English bidirectional machine translation using transformer-based transporter with attention mechanism. That is the best paper. I think the best paper attention is all you need that you have used, right?
Yes.
So yeah, first of all, I would like to go through the audience if they have any questions.
Thank you for your presentation. Did you try out different vocab size? For example, 16K,
yes.
50K?
So we have tried from 8K to 32. So we found out 32 was giving better results. So we choose as last as a final 30K.
Okay, thank you.
Yeah, any more questions from the audience? Okay.
So thank you.
So since you told that this transformer helps to translate both from Nepali to English and English to Nepali,
Yes.
how does your transformer, say, how does this works or deals with rare Nepali vocabularies, and does this supports any Nepali and English spoken language? Does this translate only the native Nepali, pure Nepali languages, or does it also supports like Nepali, English spoken languages, and that translate to some pure English or say some pure Nepali?
Oh, so currently it supports only native English to Nepali and Nepali to English as of currently, but can be done. It's difficult, but can be done.
Sure, so thank you.
Any more questions from the audience? Thank you for the question. So if none, I have a few questions. There is a large asymmetry, right, between the scores of BLU from English to Nepali and Nepali to English, right? Are you from English to Nepali, you got 32?
Can we move?
Right. Oh, sorry. From Nepali to English, you got around 21, right?
This one, yes.
And the reverse case of Nepali, English to Nepali is just 9.32, right?
9.49.
So, what is the cause of this one actually?
So, according to our research, we found that we can see to the data set size, we can see the synthetic coppers includes of 1.6 million, right? So, since English is a high resource language, English, so we can easily translate from English to Nepali, we get the result, but for Nepali to English, there is only limited, right? And also, there is no any validation, right? So, English to Nepali can be...
So, the main reason is not because of the model, it is the data set.
Yes.
Okay. That's the thing I just wanted to ask.
I would like to add up on that. So we have some grammatical issue like Nepali, we have adar and all, which translates to ma khadechu, ma khanchu, ma khanewala chu. Like that also is translated to English in similar way. So like there is no plural or...
It's the core data issue, right?
Yes,
because,
it's the core data issue.
Okay, I got your point. So, regarding the, did you do any manual checks on those data set?
Yeah. We found that in this rigorous pre-processing part, we have to validate ourselves first. So to train the model, we thoroughly checked the data set. We found that there is a repetition of characters, emojis, which are unwanted, and then so it's around 8,000 empty lines, which were completely only source data set were present and target data sets were not present. So we removed that with the coding and cleaned the data.
Okay, so I see that you have, as compared to the previous work,
yes.
right? You have increased your BLU score, right?
Yes.
Okay, so these are your BLU score, right? So, did those papers also use the same data set?
Yes, completely same.
It's completely same
But
data set, the 3 papers.
we add up a bit more rigorous processing, extensive processing.
To the data set?
Yes, to the data set.
Okay. So, and my final question. So, as we saw in the previous paper from the Nepal grammatical error correction, right?
Yes.
So, they have used a beam source.
Yes.
Right?
Yes.
So, regarding your low score on this BLU score, right?
Yes.
You have used greedy output, right?
Yes, greedy decoding.
So, did you try out beam source also?
So, since our model is completely scratch, so I want to point out something. So, this Duval et al. Uses NLLB model, which is kind of sort of pretend around with us one small data set, but our model is completely trained from scratch, from zero. So, we couldn't find the beam source implementing code, and then the NLB uses the as a library within itself, which can translate to beam source.
Could you implement that?
Yes, I will try to.
In case of if you just go for greedy, right?
Yes, but
you will lay your performance on the table. It will not. But if you can go through the beam source in your case, like whatever you have done, right?
It might.
I think the scores might,
yeah.
likely, not might, I think likely increase, right? So you can try that out as
Yes,
future.
thank you.
Okay, thank you for your great presentation, Roman.
Thank you.
So for the next presentation, I would like to welcome Mr. Sulabh Sapkota. His paper title is Video Captioning in Nepali Using Transformers.
Hello, check. Hello. Good afternoon, everyone. Imagine you are visually impaired or have a hearing impairment, or you are a Nepali native speaker who wants to retrieve a certain portion of videos, certain length of video from a longer sequence of videos. There is common in all three of these people. All of them need captions, and they need captions in their own native language. I'm Sulabh Sapkota, and with my team, we are solving video captioning problem in Nepali using Transformer. So today I'm going to walk you through the problem statement, the methodology we use to tackle the problem, the training strategy we use, and the result and discussions of our experiments. So let's get into it. Starting from introduction, video captioning is a task that automatically generates the natural language description from a video content. It is a strong tool that is used for multiple applications, like tools for impairments and content retrieval and video indexing tasks. Also, they can be used in video searching tools as well. While significant progress has been made in English video captioning, due to the low resources due to the low data set and quality of the data set issues, the low resources language like Nepali remains underexplored. This work addressed the challenges of Nepali video captioning using transformer-based architecture, combining the state-of-the-art visual encoders with multilingual decoder models. Our approach leverages transfer learning from pre-trained models to overcome the limited training data availability in Nepali. So let me be more precise about the problem statement. The existing video caption system in Nepali primarily relies on CNN and RNN models. Here is the problem with CNN and RNN models. They suffer from long range dependency issues. Thus, they can sometimes be misleading, or they can generate incorrect captions. And transformer-based approach has soon explored in Nepali due to the limited dataset resources and research focus. This gap restricts the development of accurate and fluent captioning system for Nepali video content. That's what we are solving in this experiment. The methodology what we do is we take an input video file, any format you can provide, like AVI or MP4, and it goes through a frame sampling process where based on the model we are using, we will sample frames from it. For a standard model that we are using, it samples 8 frames from 10-second videos, and then after the frame sampling, it performs the patch extraction, which is basically the work of an encoder. The encoder we are basically using is Timeswarmer encoder, which is giving best performance in our task. What it does is it performs two kind of attentions, that is spatial and temporal attention. Spatial attention means attending each patch attends to the every other patch in a single frames, whereas temporal attention will attend the patch in the different frames, but it is in a divided space time. Next, the spatial and temporal rich video embedding from video vector from Timeswarmer encoder is passed to a multilingual decoder. For our case, we are using MBARD50 decoder, which will cross-attend the Timeswarmer feature vector and autographically decode captions token by token. This is our actual model architecture we are using. The one in the rectangular box is Timeswarmer encoder model, where we can see clearly that it is using time attention and space attention followed by MLP layers. First, frame is extracted, then it is transformed. It is passed to the transformer architecture, and with the help of an adapter network, it is passed to an MBART multilingual decoder, which attends the visual feature vector in its cross attention and generates the caption token by token. Our approach combines with timestamper with fine-tuned multilingual decoder. The architectural components we use are video encoder, adapter network, and MBART 50. For visual encoder, we experimented with two kinds of visual encoders. The one is timestamper, and next one is video MA encoder. Video MA encoder basically means masking autoencoders, whose main task is to masked reconstruction, which means a large number of patches in the videos will be masked, and its job is to reconstruct the image. And the next one is adapter. For an adapter, we are using Layernum with Galio activations. Its only task is to make the input space of the timestamper model compatible with our multilingual decoder, and the cross-attention mechanism connects visual features to language generation. The adapter is initialized small with currently with standard deviation of 0.02. The exact number, we choose this exact number because in MBART implementation as well, we found that the model was initialized with the standard deviation of 0.02. That's why to make it more alignment with MBART models, we use standard deviation of 0.02 to ensure the stable training from pre-trained checkpoints. Next one is dataset. We used for dataset, we use a Microsoft videos dataset consisting of 1200 training videos, 100 validation videos, and 670 test videos. Originally, it has captions around approximately 40 captions for each videos, and in English language. So what we did is we translated the MS video dataset with different models like NLLB or external APIs like LinkBanix, and then we external APIs, and then on 40 reference captions, the total training pairs we have is 48,000, which is pretty small for fine-tuning of an timestamper model. So what it did is we froze the visual encoders, timestamper and video MA both. So this experiments with the output of the model when they are frozen. The main aim of freezing this video MA and timestamper model is because of the low data set we have to ensure that there should not be issues like catastrophic forgetting. That's why we froze the model and only train the adapter and the decoder, multilingual decoder, with a learning rate of 1 into 10 to the power 5 uniform across the decoder and adapter, with cosine learning rate and batch size of the 16 using gradient accumulation of 8. The training was done for 10,000 global steps for timestamper, where it saturated approximately around 3 epochs, whereas for video MA it saturated kind of too early in around 4K steps. The best selection is based on the validation loss. The metrics we are going to use are BLUE, which focuses on the n-gram precision, Meteor, which focuses on the precision and recall with synonym matching, ROGWELL for the longest common synonym and the fluency to test the fluency, whereas CIDR 2, which focus on TF idea, weighted consensus. What it does is, if you have important word in a sentence, then you give priority to that. That's why CIDR is also considered important. The BLUE is the most important for Nepali video caption we consider are Meteor, ROGWELL, and CIDR. So this is the loss score we obtained for timestamper plus MBART experiment. Starting early, the loss significantly dropped, and after around 2K epochs, it dropped, but steadily up to 10K steps, and after that it plateaued, so we stopped our training there. But for our model video MA and MBART, it started to saturate quite early. After 2K, 3K and 4K global steps, we didn't see the progress in validation loss. That's why we stopped the training right away, which is also seen in the matrix as well. The time summer encoder and the MBAR decoder has performed significantly better than the VDMA encoder and the MBAR decoder in all the matrices as well, in all the matrices. We obtained the CIDR of 59, Meteor 52, and ROGAL of 59, which is also better than the original LSTM based encoder decoder models. So the discussion, the time summer and MBART architecture consistently outperformed VDMA and MBART across all evaluation metrics. Time summer divide space-time attention mechanism provide more suitable for captioning and temporal dynamics in the video. Time summer is actually trained for action classification. That's why it under freezing condition as well, it provides the features which is essentially needed for the video captioning, whereas the VDMA being strong visual representation model was originally designed for max video reconstruction, making it feature less optimal for captioning generation of the video, which is reflected in low score across all metrics. We successfully implemented a transformer-based video captioning system for Nepali language, and we leveraged video encoders and multilingual transformer decoder, and successfully performed transfer learning to improve the caption generation, achieve higher meteor and the ROGAL score compared to baseline models. Thank you.
Thank you, Sulabh Sapkota and your teammate for presenting regarding video captioning in Nepali language using transformer. So, as usual, I will take a few questions from the audience. Yes, sir.
Hello. So, video captioning in Nepali ma चाहिँ suppose normally भिडियो र अब गुगल ट्रान्सलेट र अडियो पनि त्यो गर्छ नि त, अडियो पनि ट्रान्सलेट गर्छ नि त हैन. अब हामीले कुनै पनि एउटा भिडियो नेपाली भिडियोलाई त्यसको अडियो मात्रै एक्सट्र्याक्ट गरेर गुगल ट्रान्सलेट जस्तो सफ्टवेयर लाइक गुगल ट्रान्सलेट जस्तो एआई युज गरेर चाहिँ ट्रान्सलेट गर्न मिल्छ कि मिल्दैन? इफ मिल्दैन भने डिफरेन्स चाहिँ के हो यसको र अडियो ट्रान्सलेसनको, त्यो चाहिँ थाहा पाएको हुन्थ्यो.
अडियो ट्रान्सलेसनबाट उ गर्ने भन्नुभएको हैन, के अरे युजिङ अडियो इज के भन्ने हो, अडियो युजबाट गर्दा पनि मिल्न त मिल्छ, तर यसलाई चाहिँ हामीले चाहिँ मल्टिमोडल एक्सपेरिमेन्ट चाहिँ गर्न खोजेको, जसमा चाहिँ हामीले चाहिँ भिडियोकोबाट चाहिँ थ्रु विथआउट युजिङ अफ अडियो पनि हामीले चाहिँ जेनरल क्याप्सनहरू चाहिँ पहिला चाहिँ निकाल्छौँ, अनि पछि अब मल्टिमोडल अरू पनि मिडियाहरू चाहिँ थप्न सकिन्छ, जस्तै अडियोहरू, जुन चाहिँ हामीले चाहिँ फ्युचर वर्कमा चाहिँ गर्न सकिन्छ.
गुड क्वेसन हैन. अनि त्यसरी गर्यो भने कुन चाहिनेको पर्फर्मेन्स राम्रो होला त?
त्यसरी गर्यो भने अडियोवालाको राम्रो हुन्छ.
अडियोवालाकै राम्रो हुन्छ.
अडियोवाला प्लस भिडियो सहित गर्यो भने चाहिँ राम्रो हुन्छ.
So, any more questions from the audience side? Please feel free to ask your questions, right?
Anyone?
Okay. Yeah, I have just a few questions regarding your data set, right? So, you said this MESVD data set, right? I think this data set is originally in English, right?
Yes, sir.
It is originally in English data set, video captioning for English data set it is, right? So you mentioned that you generated Nepali captions for those videos.
Yes, we tried.
How actually did you accomplish that? Using other models?
Yes, sir. We used one model named NLLB for that purpose. One is that, and another is external application as well for that purpose. And we manually verified as well. We, as a team, manually verified the error and removed the captions that are incorrect in it.
Actually, like if you try to do that in that way, right, you are actually using another model to generate a Nepali caption, right? So I think the performance of your model, you are trying to put a ceiling effect on of that model from which you have generated Nepali caption. So if you have manually checked all of the levels, right? Yeah, in that case, I think it is a pretty good work, right? So I got a bit confused because the abstract that I got from the college, like there is another performance metrics, right, regarding CHR F++.
Yes, sir.
So why didn't you mention here?
Sir, we
because that is also quite important, right? I see your other performance metrics are quite good,
yes,
right?
Yes, sir.
But your CHR F++, which takes into account the morphological sentences also.
Yes, sir.
Why didn't you mention here in your slide?
We are quite confident about it, sir, because of the way it was calculated.
Or you were not confident how
Yes,
you
sir.
calculated it on the paper,
Yes,
so
we
that's why
also
you...
calculated another matrix called BOT score, which uses BOT embeddings to match the semantics between the references and the prediction. But that also uses XLM Roberta large model, which was not pretty accurate. We thought was not accurate, and because of that, we are not confident, and we didn't put that one as well.
Okay, so this, in your abstract, you have CHR F++ of 25.21, right?
Yes,
Which
sir.
is kind of a moderate
Yes.
on the character level. Have you put this on your actual paper also?
No, sir.
No? Okay. So, for last question, it's just a extension of your work. So, this dataset, like MSBD dataset also, right? It's like for everyday operations, right?
Yes, sir.
Those videos contents. How about if I put a video of Nepali ritual festival? Will your system be able to generate a good quality of text?
So basically we train Timesformer model is trained on the Kinetic 600 dataset. That is the dataset of 600 human activities basically. So if we give the videos related to the festivals, it may not perform well.
Thank you. That is all my question. Thank you. So this is the last presentation. So this last presentation will be presented by Mr. Adarsha Shrestha. His paper title is Towards Nepali Language LLM Efficient GPT Training with a Nepali BPE Tokenizer. Please welcome him, everyone.
A warm greetings to everyone present here, respected session chair, guests, fellow delegates, and my fellow research presenters. So our topic is Towards Nepali Language LLMs Efficient GPT Training with Nepali BPE Tokenizers. So here's the presentation outline for today. So introduction. So transformers have transformed how we behave or how we perform in our day-to-day activities, but is primarily dominated by highly resourced languages like English. But Nepali is spoken by over 32 million people and still represents very underrepresented in NLP research. And because Nepali has a very complex grammar, agglutinative morphology, and a flexible sentence structure, making the modeling more difficult. Existing NLP work is mostly decoder-based, like NebBERTA, but the generative decoder-only based are lacking. So this is why we worked on a GPT-2 based generative Nepali language model inspired by GPT-2 and GPT-3 training strategies. So the problem statement for our project was that there is no high-quality data set available for languages like Nepali. And general purpose tokenizers poorly represent Nepali subwords, harming the model efficiency. And training LLMs are computationally very expensive in a resource-constrained settings, and that's why it needs efficient training strategies. So the methodology that we used for our project, it can be broken down into data, pre-processing, tokenizer, architecture, and training itself. So for the data set, we combined NebBERTA corpus, and we also scraped fresh data from sites like Ikantipur, Setaparty, Ratoparty, and we purposely excluded data like Oscar because there was a lot of redundant data and the data was pretty noisy. So next step is pre-processing. So for the pre-processing, we used regex filtering. We removed the HTML, the English words, the URLs, and only used Devanagari. And we removed the deduplicates, fetching us a 10.75 GB database. Next is the tokenization step. So for the tokenization, we use sentence piece library to curate a BPE tokenizer having vocabulary of 16,000, and which is trained on 8 million characters. And the corpus was split into 87 shards, each containing 10 million tokens. So next is the architecture. So for the architecture of the model, we used GPT-2 architecture, that is the small one, which has 12 layers, 12 heads, and an embedding dimension of 768, where we obtained a rough parameters of 98 million. Next, we integrated flash attention, which is not there in GPT-2, for efficient memory utilization. And we trained the model for 2 epochs, that is roughly 3,300 steps, and we used a microbatch size of 8. And since GPT-2 has a batch size of nearly 500,000, and that is not really feasible for our system, so we use a clever technique called gradient accumulation, where we use a microbatch size of 8, and we accumulate the gradients over 64 steps, accumulating a total of batch size of 500,000. And we used a cosine learning rate decay with a maximum learning rate of 6 into 10 to the power minus 4 and a minimum learning rate that is 6 into 10 to the power minus 5, and use AdamW for optimization. And another clever technique that we used is bfloat 16 precision. So what the bfloat 16 precision does is it brings down the it halves the memory utilization, bringing the total bits that we use from 32 to 16. So next, here is our results. So for the results, we can see we have observed a perplexity of 21 with a training loss of 3.1 and validation loss of 3.0. Here's our training graph for our work. And finally, a perplexity of 21.8 for a low resource GPT-2 model is very strong, and the training loss is 3.16 with a validation loss of 3.082, which shows good generalization. The perplexity dropped from 18,000 to 21.8 across 3,300 steps, which shows consistent convergence. And the model generates coherent, contextually relevant Nepali news style text across multiple domains. So conclusion. So we successfully trained a GPT-2 Nepali language model, achieving a perplexity of 21.80, and we trained a custom 16,000 BP tokenizer trained exclusively on Nepali text for better subword representation. We used flash attention, gradient accumulation, and bfloat 16 for training under GPU constraint. And for the future work, we can employ a larger model, more diverse data sets, and improved fine-tuning models. For maybe we can use instruction models and other downstream NLP benchmarks. Here are our references for our work. Thank you very much.
That was our last presentation by Adarsh Shrestha. So, lastly, first, I would like to go through the audience. If they have any questions, please. Okay. Any questions? So yeah, I think you are all using ChatGPT, right? So this is actually a custom, not any pre-trained models, right? They have actually built a large language model for Nepali language. They have built a custom tokenizer. You don't have any questions? Okay. So yeah, good work. So instead of just not relying on multilingual models, you have gone through training your models from the scratch, creating a 16K byte pair encoding, right?
Yes.
Tokenizer. So a few questions regarding that. So is that 16K is that vocabulary size optimal? Did you try with other sizes?
Okay, thank you very much for the question. So that was the question that we asked ourselves, and we are currently doing a research regarding that. So we are utilizing various different vocabulary size and various vocabulary, not only vocabulary size, but also different techniques of tokenization. So not only byte pair encoding.
And is it like if you have already tried, right, one or two cases of different vocabulary size?
No, we are currently in the process of doing that.
Okay, okay. So I was a little curious, like if you tried with different vocabulary size, does it affect your perplexity score? You haven't gone through that. You are trying that out.
It's a research that we are currently working on, but the preliminary results say that the higher the vocabulary size used, so we have gone through 16,000, 32,000, and 50,000. So the higher the vocabulary, the better the results we are getting.
Okay. So your training, like you have how much? 11 GB of dataset, right?
Yes, 10 GB.
Around 11 GB. So you mentioned that you have only trained for 2 epoch, right?
Yes, sir.
So why did you stop on 2 epoch?
So that was primarily due to the resource constraint that we had and the time constraint for putting out our paper. And the 2 epochs was pretty good for inference as well. So we tried inferencing on the model. It was giving pretty generalized, pretty good responses.
Did your model converge at 2 epoch?
It was on the verge of converging. So right now we are also extending that to train across multiple epochs.
Could it be that you might get a better perplexity score if you go for a bit higher epoch? Could it be possible?
Yes, it is possible, but it's only marginally better.
Okay, so the last question for you. You have developed a very good work on Scratch, training the Scratch ChatGPT model, right?
Yes, sir.
But if you look at perplexity, it is an intrinsic matrix, right? So I think it might be just a good suggestion for you guys. Like, are you able to check this for any downstream tracks, like for machine translation, for text summarization? Are you planning to do that?
Thank you very much for that question. So that is something that we are currently doing. So we are using our model, fine-tuning it for summarization, and then we are evaluating our model on ROC score for summaries. So that's something that we are currently doing.
Okay,
so that's one of the limitations of this paper.
Machine translation?
What is the translation? Summarization.
Text summarization?
Yes, sir.
Okay, you are trying to include that and go for maybe journal publication?
In our next paper, yes.
Okay, that is all my question. Thank you so much.
Thank you very much.
Thank you, everyone. With this, we have successfully concluded all 6 paper presentations for this session slot. I would like to sincerely thank all the presenting teams for their outstanding research contribution, insightful discussions, and dedication to advancing knowledge in the respective fields. Now, we shall move forward to the certificate distribution ceremony for all our paper authors. For this, I would like to respectfully invite our session chair, Dr. Bipun Manpati, to kindly come forward and join us on the stage for the certificate presentation. Thank you, sir. I will now call the presenting teams one by their paper IDs in order of the presentation. Firstly, paper ID 1207, Fallacy-Aware Argument Analysis and Improvement Using Structured Argumentation and Large Language Models. May I invite Jayadev Tripathi and Sanjeev Kashti to please come forward for the certificates. Let's give them a huge round of applause. Thank you. You may kindly take your seats. Next, we have paper ID 1208, Continuous Learning for Research Assistants, our Q-LoRa-based multi-agent approach. May I invite Ashish Pandey, Pranjal Regni, and Devesh Parajuli to please come forward. Next, we have paper ID 1246, Nepali Grammatical Error Correction. May I invite Rohit Basukala, Saman Gosai, Sumit Lasiwa, and Tuyal Shrestha to please come forward. Let's give them a huge round of applause. I'd like to request Rohit Basukala for the group photo too. Please join on the stage for a group photo too for your team. Session chair some group photo. Group photo. Thank you. Next, we have paper 1248, bidirectional Nepali English neural machine translation using attention-based transformer. May I invite Nashim Deola, Roman Kasichwa to please come forward for their certificates. Thank you, team. Next, we have paper ID 1251, video captioning in Nepali using transformers. May I invite Sandeep Sanjay, Sulabh Sakkota, Aman Shilpakar, and Sujan Acharya to please kindly come forward for the certificates. Thank you. Last, we have paper ID 1256 towards Nepali language LLMs, efficient GPT training with a Nepali BPE tokenizer. May I invite Adarsh Shrestha, Basanta Pokhrel, Binit Shrestha, and Smriti Adhikari to kindly come forward for their certificates. Let's give them a huge round of applause. Thank you very much. Once again, congratulations to all our presentators for their valuable research contribution, and a sincere thank to our session chair, Dr. Bipun Manpati, for graciously presenting the certificates. Now, as we conclude our technical session slot 1, we would like to express our heartfelt gratitude to our respected session chair, Dr. Bipun Manpati, for expertly managing the session, guiding the discussions, and providing valuable feedback to all our presentators. To present a token of appreciation, may I request Engineer Bikas Sharla sir, Head of Department of Computer Engineering at Khopa Engineering College, to kindly come forward and offer the token of love to our session chair. Let us again give him a huge round of applause for his invaluable contribution.
टेक्निकलहरु तल बस्नु
Thank you, everyone. Please take your seats. With this, we have officially concluded the slot 1 of the technical session. We now have a lunch break of 1 hour. May I kindly request all participants to reassemble in this hall after 1 hour for the guest speaker session, followed by a slot 2 of the technical presentations. Please be punctual so that we can continue the program smoothly as scheduled. Enjoy your lunch, and we look forward to seeing you all again shortly. Thank you.